So do this question for you. Modulus function. Let's do this question, बच्चा लोग. So what type of this question? Figure 3 shows a sketch part of the graph with equation fx is available, k is positive constant. The graph curves the y-axis at a point and has a vertex at p point. Okay. So find the simplest form in terms of k for the y coordinate of a and the coordinates of p actually. Yes, bacha log, how can we figure out the coordinates of a point? Very easy. A point has x coordinate is 0, obviously because it is lies on the y-axis. So put for a point, put x equal to 0 into this function. So it is going to be equal to 0 times k will become 0 minus 10 minus 10. Yes, everyone knows the modulus of negative number will become positive. These are the main important features of modulus function. So the y coordinate is actually 10 plus k. So the point of A is 0 comma k plus 10. Perfect. So what will be the coordinates of P? For P is actually vertex. P is the vertex. Everyone knows how to figure out the vertex point. Put this bracket equal to 0 and find the value of x, which will be 10 over k, and that is the value of y is always, everyone know that. So what will be the vertex point? X is 10 over k and y is k. I don't think that would be a difficult question. So let's do next question. Find the range of the values of x which satisfy kx minus 10 modulus plus k. Everyone knows beta. What type of this question? Type 3 of modulus, which is modulus with inequality. Modulus with inequality on one side. So what type of method I need to use for this question? Graphical approach. Yes, you know that. So graphical approach. This is the graph of y equal to modulus of kx minus 10 plus k, which is already given. Alright, perfect. This is already given. Let's make a graph of y equal to 2k. K is a constant beta. Y equal to any constant number. What type of this line? Horizontal line, bachcha log. Horizontal line. So let's mark the point of P, 10 over k, comma k, and a point is 0 comma how much k plus 10. Alright, so that value is actually k. So where will be the value of 2k? 2k is actually, obviously it is lies above the k value. So that should be a horizontal line. So horizontal line is going to be intersect at how many points? 2 points. So find the point of intersection. Yes, everyone knows this line is actually going to be open with negative sign. And this line is actually going to be open with positive sign. Perfect. Now let's do. Just you have to find the point of intersection. So first point of intersection with y equal to 2k line, this point. This is the point of intersection between y equal to 2k line and this line which has the equation like this, minus kx minus 10 plus k. So put equal to each other beta and get the values of x actually. I hope everyone knows how to solve simultaneously. So 2k is actually equal to minus kx plus 10 plus k, and kx will be equal to 10 plus k minus 2k. K minus 2k will be equal to 10 minus k, and x equal to 10 minus k over k actually. So what is the next point of intersection? X value is 10 minus k over k actually. So the next point of intersection between this line and this horizontal line means y equal to 2 equation, and what is the equation of second line? This is kx minus 10 plus k with positive sign. So put it equal to each other and find the value of x. So kx equal to 2k minus k plus 10. So kx equal to, bacha log, I hope you can do easily this simplification clearly. So 2k minus k will become k, and x is actually equal to k plus 10 over k. So please remember, whenever you have a question with inequality sign in modulus function, always do by using graphical idea. Make the graph of both of them and find the point of intersection between both of them. Straightforward. So how to write the final answer, everyone knows. Alright, so this is our horizontal line and this is our modulus function. That is a graph of modulus function which is greater than. Greater than means above area. Alright, so let's stand up. Now we have to stand at the point of intersection. Point of intersection is 10 minus k over k, and the second one is k plus 10 over k. Perfect? Perfect. Just let's talk about point of intersection. Your modulus graph is greater than or equal to 2k graph. Greater than means above area, you have to shade that one. So which part is the above part for modulus function? At the point of intersection, this part is the above part actually. Shade it. Then beta, this part is shaded. Should I need to shade it actually? Always remember how to shade the last part beta. You have to stand at the point of intersection and check it. Your black graph, which is modulus function graph, is greater than 2k, means it is above than 2k. So at the point of intersection, which part of the modulus function is above area? This one or this one? Common sense is this one. At the another point of intersection, which part of the modulus function has above area? This part or this part? Obviously this part. Shade it. So this area, this shaded area is left side of the point of the intersection, and this shaded area is to the right side of the point of intersection. So the final answer will become, that is the right side of values of x. Right side means greater than, and this area is actually left side of, left side means less than 10 minus k over k. Even you can connect both of them at the end. X is greater than k plus 10 over k and less than 10 minus k over k. I know that was the confusing part for a lot of students, sir, how to shade at the end of the question actually in inequality form. I know that, but be careful. I always told you, so don't worried about that, don't hesitate about that, sir, what I am doing, what I need to do. It's very straightforward actually. Your modulus function is above than your 2k graph. So where you have to stand actually, please always check at the point of intersection. Just stand on the point of intersection and check where the part of the modulus function is above, this one or this one. Obviously this is above part. Alright, clear, finish, done, perfect. Let's move forward. Alright, so given that the line with equation y equal to 3x plus 1 intersect the graph of y equal to fx at two distinct points. That is the graph of y equal to fx, and let's make a graph of y equal to 3x plus 1. So how to make a graph of straight line? Find x-intercept or y-intercept. Everyone knows that is a special question in our complete modulus function, where the line and curve can be intersected at one distinct point or maybe two distinct points. I hope everyone remember this idea. What do you have to do? So let's make a graph firstly. So put x equal to 0. So y will become 1. The point is 0, 1 actually. So the graph should be passes through the y-axis at 0, 1. So I can make a graph of y equal to 3x plus 1 like this. What is the vertex point of graph? 10 over k, k. And everyone knows what is the another possibilities. I will describe again what is the reason behind that. I can make a graph like this. Yes, 3x plus 1. Maybe I can make a graph like this. So there are two possibilities. Let's talk about first possibility, about this one. If your graph would be like this, then what we need to do, everyone knows. Obviously beta, this point is lies on this line, so I will put this point into this function. Y value is 10 over k, x value, no, sorry, it's my mistake. Y value is k, x value is 10 over k. So now what can I do? 30 over k plus 1, k equal to, take LCM to the right hand side. Any issue? I don't think there is an issue about algebraic ideas. So let's make in quadratic. Find the value of k. I think it can be factorized. Minus 6k plus 5k. So you can figure out the value of k. We have done these 2 to 3 questions related with two distinct points and one point in notes in topical. So I told about this type of question clearly in topical questions actually. Why I'm doing like this. So find the value of k actually. So the k value will become minus 5 and k is 6. In this question k cannot be negative, which is given. So k is only 6 actually. K is only 6. K is only 6 value, means what is the y value over here? Y coordinate is 6 actually. The y coordinate of vertex point, is 6 actually. Clear? Alright, clear. No problem. How to write the final answer for first one? if I will make a graph of y equal to 3x plus 1 like this, so it will always going to intersect at only one point. But what is the question? Question is, this graph should be intersect to the graph at how many points? Two distinct points. Because that is only possible if the y coordinate of turning point will be less than 6. Look at the screen. Yes, everyone knows, if I will shift this turning point in downward direction like this, let's say I'm trying to make a modulus graph like this. Now green line will intersect the pink graph at two distinct points or not? Think about that in your brain. Yes. So that is only possible if this turning point, obviously beta, this k value is 6. So this, which is y coordinate, so obviously beta this will be less than 6, which is y value, because it is below to the another turning point. So please be careful. I told you in notes, let me explain again what I want to tell you. Look at the screen. This graph is going to intersect the black graph at only one point. But what I want to get your graph is actually intersect the graph at how many points? Two distinct points. That is only possible. So that is only possible if the y coordinate of this graph, if the y coordinate of turning point of this graph will be less than this turning point. So what will be the final answer? K is less than 6 for this one. So what is another possibility? I told you in notes, another possibility is maybe this line is going to be exactly parallel. This line of y equal to 3x plus 1 is going to be actually exactly parallel to this line. Obviously if it is parallel, so what is the gradient of this line? 3. So what will be the gradient of this line? Obviously also 3 if they are parallel with each other. What is the equation of this line? Equation of this line is y equal to kx minus 10 plus k. What is the gradient of this line? M is k. So it means the gradient of this line is 3, which is k value. So this line has k value is 3 actually. But the problem is they are parallel with each other. Then the gray line is going to be intersect the graph at how many points? Only one point. But I want to get two distinct points. That is only possible if your modulus graph is going to made like this. Check it. Yes, this line has greater steepness or this line? Obviously this line. So when the steepness will increase, then these two graphs can be intersected at two distinct points. When the steepness will increase, steepness, what is steepness? 3. If gradient will increase, so obviously they can be intersect with each other at two distinct points. Let me explain again what you have to do in this question. Whenever the question is given that the line intersect another modulus graph at two distinct points or one distinct points. Let's talk about two distinct points. There are two possibilities. First, you need to make a graph of straight line. And how to make a graph of straight line? There are two possibilities. First time you have to make a graph which is going to pass through the vertex of the modulus function. That is your first possibility. If it is going to pass through the vertex of the modulus function, so I can put this point into this line. So please just put this point into the line and get the value of k. K is 6. Now the k is less than 6 or greater than 6? I don't know. Beta, range values, everyone knows what is the meaning of range. He is talking about your answer should be in inequality form. So how to write the final answer with inequality form? K is 6. What is the value of K? K is 6. If I will shift this turning point in downward direction, so your green line is going to be intersect to the modulus graph at how many distinct points? 2 distinct points, because we want to get 2 distinct points. If you want to get only 1 point, so obviously no need to shift your turning point to the downward direction. If you want to get 2 distinct points between green line and red graph, check it. Now actually it is going to intersect the graph at only 1 point, but we want to get 2 points, so you have to shift your turning point into the downward direction. So when you will shift your turning point to the downward direction, obviously beta, when now your y coordinate is 6, so now your y coordinate will become less than 6. Common sense. If this one is y coordinate is 6, so obviously this one will become less than 6. Common sense. Alright. So always write the final answer with inequality in range of question. Alright, so what is another possibility? Your green line maybe is parallel to this black line, but the problem is your green line is always going to intersect the black graph at how many points? At only 1 point. Green line exactly parallel to this line. So when the two lines are parallel, obviously it has same gradient. So the gradient of this green line is 3. So then the gradient of this line will also become 3. Done? Alright, but the problem is green line will intersect at only 1 point. That's the problem. But how many we want to get points? We want to get 2 points. How can you get 2 points? That is only possible if this line will get greatest stiffness. Greatest stiffness. Alright, so obviously beta, this line have greater stiffness than this black line, so that is only possible when m is greater than 3. M is actually k, and k is greater than 3. So your final answer will become k greater than 3 and k less than 3. We did this type of questions in our modulus function. We will always almost have 2 types of questions on distinct points in modulus function.